Academy problems just to kind of refresh our minds on what we did this chapter. I do. Okay. So, what's the value of the first derivative of the sine of 2x minus pi over 3? What do we do? The cosine of 2x minus pi over 3 times 2, because of the chain rule. Okay? So, if we put in pi, what's 2 pi minus 1 pi over 3? 5 pi over 3. What's the cosine of 5 pi over 3? Do you guys have unit circles, right?
Yeah.
It's 1/2, and it would be positive 1/2. And 2 times 1/2 is 1. Okay? We're good? 3 cosine cubed of x underneath the square root. So I would rewrite it as 3 cosine of x to the 3/2 power. Because that's really what it is. Okay? Because cosine cubed, you put the cubed on the, No, that's not what it is. Dang it. I was going to make that too easy. So it's basically the square root of 3 times the cosine x to the 3/2 power. Because it's just the cosine's cube, not the 3. Okay? So, if we do this, first step. Chain rule. So 3/2, so it's 3 square root of 3 over 2. And then cosine of x to the 1/2 power times the first derivative of the inside, which is negative sine of x. So, so it'd be negative 3 sine of x square root of 3 cosine of x over 2, which doesn't match with any of them yet. I mean, it's really close to this one.
So it must be C.
I would guess it's C, but I'm going to have to do this. Since it doesn't match, we're going to have to do this another way. Okay? So, let's just do it the U method. U equals 3 cosine of x cubed. So what's du for this? 9 cosine squared of x sine, negative sine of x, so it's negative out front. Okay? So then we have the square root of u, so that's u to the 1/2 power, which is 1/2 u to the negative 1/2, which is 1 over the square root of u, is the first derivative of that, right? So it's 1, quit it. Oh, get out of there.
All right. 1 over 2 square root of u?
1 over 2 square root of u. Yep. All right. So then, insert u, and then you have to put the du on the end. So 1 over 2 square root of 3 cosine cubed of x times negative 9 cosine squared of x sine of x.
So B.
So that's what B is. Okay. There we go. Second derivative of that. Well, we start with 6x to the negative second. So the first derivative of that is negative 12x to the negative third. Second derivative is positive 36x to the oh, I just have that on there twice for some reason. All right. So we're figuring out f of g or f of h of x, find the first derivative at 2. So it's, you find h of, so it's the first derivative of f, right? Times h of x so the first derivative at 2 of h of x is negative 1. So then at negative 1, we find the first derivative of f, which is negative 5. And then the first derivative of h at 2 is 6. So then you multiply negative 5 times 6 is negative 30. Remember that?
Yep.
Okay. Arctan of 2x. So arctangent is 1 over 1 plus x squared, right? Times dx. So it's 1 over 1 plus 4x squared times 2. So if you stick a negative 2 in for there, it's 1 over 1 plus 16 times 2. So it's 2/17. F and G are inverse functions. So we go 1 over f of first derivative of f at g because if we have g prime of negative 2, is it because the 5 leads us to there, which puts us here. So it's 1 over negative 1/2, which is negative 2 with no multiplying. Okay. All right. What is our original function here? 7e to the x at 4. Okay. So the first derivative of this would be 7e to the x dx. And so you stick the 4 in. So it's going to wind up to be 7e to the 4th. second derivative of this at that point. So let's find the first derivative. What's the first derivative?
3x squared plus 2y dy dx.
Equals 0. So what does dy dx equal?
Negative 3x squared over 2y.
Okay, so then when we take the second derivative of it, it's the second derivative. It's 2y times negative 6x minus negative 3x squared times 2 all of dy. Ooh, I forgot the dy dx. Over 2y squared. Okay, so it's negative 12xy plus 6x squared times 3x squared, negative 3x squared over 2y over 4y squared. Then we can just stick in the x's and y's for x's and y's. So if we stick in a 2 and a 4 and a 2 and a 2 and a 4 and a 4. So we get negative 96 plus, this is negative 12, this is 24, correct? So that's negative 288 over, over 8 all over 64. 8 goes into here 3 times 48, 36 times. So it's negative 96 minus 36, which is negative 122, 132 over 64, which reduces down to 33 over 16. What?
We did that problem earlier, and I said negative 32 over 16.
Mm-hmm. Inner and outer functions. The inner is the square root of x. The outer is the log. Hopefully you got that down. Cosecant of 3x over x squared, what would you do? Well, quotient rule and the chain rule, because the top is a chain rule. So it's quotient rule, chain rule. Find dy dx. The first term is the what rule? Product rule. So it's 2x dy dx plus 2y plus 3x squared minus 6y dy dx equals 0. Everybody good with that? Okay. And then, so it's 2x minus 6y dy dx equals negative 2y minus 3x squared um 2y minus 3x squared, 2, yep, should be choice A. Jacob tried to solve this problem. Where did he go wrong? Hey. So that's the right, and that's right. So putting it together, taking the derivative of that. Product rule?
Yeah, that's not the right product rule. You don't multiply the derivatives.
Right. He did not do that. Jacob did not state the correct product rule. How would we do this so we could do the power rule? Just distribute the x. Easy peasy lemon squeezy. What is that? Because it's the sine of x to the 7th power, right? So it's 7 sine of x to the 6th times cosine of x, which is that one. That's it. My biggest bugaboos that I have difficulties remembering sometimes are these table ones because I get them mixed up with the inverse ones. What?
I've never seen the No, I've definitely seen the multiply one time.
I remember from like way back when.
Yeah.
I remember from a long time, like a couple chapters ago.
No, that's this chapter. That right at the start of this chapter.
I just assume you cram so much in that it's probably the same chapter.
Yep. It's because the inner function, outer function stuff is right near the start of the chapter. So, all right. So that was the little cram session. So I'm putting the Khan Academy test out now. And then on Tuesday, we'll review for the AP classroom test. And Thursday,